My name's Hexagonic, and I'm going to teach you math today. So I'm going to introduce you to the gateway drug into complex algebra, known as polynomials. So a polynomial can be categorized in many different ways based on how many terms or how many parts of an equation separated by a subtraction or an addition symbol inside of the equation. So a polynomial with one term, or an equation with one term, would be a monomial. Two terms is a binomial. I don't know where that label went. Three terms is a trinomial, and anything above four terms is just a polynomial. So degrees are the measure of the leading term's exponent. But for a constant, even though constants have an exponent of 1, they will have a degree of 0, and anything with a variable, so a coefficient or maybe just x, has a degree of 1, which is linear. So anything that is squared has a degree of 2, which is quadratic. So quad does not mean 2. Quad doesn't mean 4. Quad means 2. Sometimes. Anything above the power, or anything that has a power of 3 has a degree of 3, which is cubic. Anything with a power of 4 has a degree of 4, being quartic. Anything with a power of 5 has a degree of 5, being quintic. And anything that's to a power above 6 has a degree of that number, which is above 6, being the nth degree. So in the disgusting world of polynomials, everything has to be simplified. So polynomials are ordered from the greatest degree to the least degree. So this is an unsimplified polynomial. It's disgusting. We hate it. So we're gonna simplify this. So we're gonna look at our first term. What the fuck? I don't like this whiteboard. But we're gonna look at our first term. See how it's not the highest one in the term, so we're gonna take it out for later. So 3x to the power of 2 has the highest degree here. So we'll put that one first. 4x also. So this has a degree of 2. This has a degree of 1, and 3 has a degree of 0. So we will put 3 at the back if it doesn't put an enter where I didn't press it. Then we get our then we get our simplified equation: 3x squared plus 4x plus 3. And since because we have a coefficient in our in our leading term, this is our leading coefficient. So now it's time for the easy part, which is solving binomials. Now there's two ways we can do this. We can do the area method, or we can do FOIL. So FOIL states that we should multiply the first terms, the outer terms, the inner terms, and the last term. So this is how we do it. Multiply the first two terms. So x times x to get x to the power of 2. Outer terms, so x times 5 to get x, or 5x. Inner terms to get 3 times x, which would be 3x. And our last terms to get 3 times 5 to get 15. So we would simplify this, and you should always have your two middle terms being combined if you simplify it correctly. So we would add 5x to 3x, which is adding to the rest of the problem. And we can combine 3x and 5x as their like terms because they have the same variable. So we get we get a simplified trinomial being x squared plus 8x plus 15 being our simplified trinomial. Probably should have done this before the binomials, but here's how you add or subtract a polynomial. You just got to combine the like terms. So for this equation, we have two trinomials we can add together. So we have 3x plus 21y plus 3 being added to 22y plus 4x plus 7. Now we can combine those like terms to get 3x plus 4x plus 21y plus 22y plus 3 plus 7. And then we can simplify that to get 7x plus 43y plus 10. Now, for subtraction, it would be the exact same, but instead we would make the second term the inverse of what it is. So multiply everything by -1. So it would be negative 22y, negative 4, and negative 7. This is an example of a problem you'd be given. So we have find a, or big A, so little a is equal to h plus 90, b is equal to 2h plus 84, and big A is equal to half h times a plus b. Now, we're going to use these two binomials to substitute these two. So it's adding binomials with these two. And then we're going to multiply it by this, which is multiplying a monomial and a binomial. So, what you're going to do is you're going to take out a piece of scratch paper and do this on your own. Pause the video, and when you're done, unpause it. If you did your work correctly, you should have taken our original equation and substituted a and b for h plus 90 plus 2h plus 84. And we should have combined the like terms, so h plus 2h and 90 plus 84 to get 3h plus 174. And then we multiply it by half h from the original equation to get 1 1/2 h to the power of 2 plus 87h is equal to a, or area. This is another common equation found in tests where you have a tiny square and a big square, and in between the edge of the tiny square and the big square there's an x distance in between. Now my square isn't perfect because I'm not, but then the total area is 60 by 70 for the inner square, right? So I have to figure out how large it is if the inner square is, I should move this actually, right here. Okay, so 60 by 70, and the space in between is x. So right here, so 60 times 70 would be the inside of this square, the tiny one. But we need to find the area of this big one. So we're going to add x to each of these values. Well, 2x, because there's x on this side, there's x up here. So 2x plus 70 times, because the area is length times width, 2x plus 60, because there's also x on both sides of this 60 in the way. So we get a binomial, which when solved with FOIL or area model, whichever one is your choice, you will get 3x plus 70, 2x plus 60. No, that's when it's simplified. I'm reading out my book. That is the equation. And when you solve, you should get 4x to the power of 2 plus 260x plus 4,200. And this is reflective of the area of this gray thing. So, we're going to start factoring polynomials. So, we're going to start with special products. This is the easiest way to do it. So, if you see an equation that looks like this, where a squared plus 2a times b plus b squared occurs, right? This will be the factor of squares. So this is equal to a plus b to the power of 2. So if you factor this out, you get a times 2, a times a squared, b times b squared. Then you multiply these two to get 2ab, combine them to get this. So when you see this, you can instantly factor down to a squared and b squared. Now, another special product would be one for the factor of a difference of squares, which would be this, so the equation would be a to the power of 2 plus 2, minus 2ab plus b to the power of 2, which will be equal to this equation, but it's minus b instead of plus b, like that. So this is factoring. So this is factoring by GCF. So as you can see here, we have a trinomial. Now every term in this trinomial has an x, so we can guarantee that, and every term here is divisible by 3. So what's going to happen is our GCF will be equal to 3x. That is our greatest common factor. So we'll have an equation like this, where we multiply our greatest common factor times all of our terms divided by the greatest common factor. So 3x to the power of 3 divided by 3x is x to the power of 2. 9x to the power of 2 divided by 3x is 9x, 3x. And 12x to the power, and 12x is just 4. Because we have no more common factors, that means we found the greatest common factor. So this is our fully factored equation. Another way to do this is the x method, which is where you draw a ginormous x. A very abnormally large x. You put numbers inside of it. So our equation for this is going to be a certain type of trinomial. And this certain type of trinomial is going to be a can I move it? So this trinomial is going to be an equation set up like this: a times x plus a times x to the 2 plus b times x plus c. Now, this equation right here can be put into this x formula to be simplified. So, what we can do is we can put, what the fuck up? We can take a times c, and we put it at the top, and we get, what is it, b at the bottom. Now here, we have to find the factors, so our factors of a and b, or a and c, be m and p. Now, for this to work, m plus p needs to equal b, but also m times p has to equal a times c. So let's get an example equation. Let's take this formula, and we can do, I don't know, 3 times, let me get a factorable equation, because I want to do a prime one. 1 second, let me look at it. X squared minus 9x plus 18. So we have x squared plus negative 9, so we can simplify that to be minus 9, which is 9x plus 18. Now, since a is 1, we can just put c up here. So c is 18. Let me make this bigger. Put it down here. So c is 18. B is negative 9. So we're going to look at this and we're going to say, well, MP, so to get negative 9, something has to be added to 18. So look at the factors of 18. Since b is negative, one of the factors will be, the two factors will have to also be negative, but they'll have to add to this. And since this number is positive and b is negative, if it were vice versa, then one negative would be, then the smaller number would be negative and the larger number would be positive. And if they were both negative, then the smaller number would be positive and the larger number would be negative for your M and P. So, looking at our factors of 18, if you have your negative factors of 18, since this is negative, our smaller number, or both numbers, need to be negative. So our negative factors of 18, I won't list them all, but the two that we need are negative 3 and negative 6, because when these are multiplied together, so this is our M and our P, so you put those right here. So, negative 3 and negative 6. And when you multiply these two numbers together, you get positive 18, but when you add them, you get negative 9, making this a factorizable equation, so it is non-prime. So we get x, and you're going to want to plug your numbers into your original equation so we can solve it. So we get x squared plus 9 plus negative 3x plus 6x, or no, minus 6x plus 18. So now what's going to happen is we're going to learn how to factor by grouping so we can solve this, because this is not simplified yet. So we can move these guys out the way. So with our factorized equation, but it's not fully factored, so our semi-factorized equation, we can take this and we can factor by grouping, where you group these. It's for polynomials of 4. So if they're at least 4 terms, because you can do this with more than 4 terms, you have to group them into groups of 2, and you're going to add, or we're going to simplify them. So just like how we did with the GCF, we're going to find the GCF so we can guarantee at least one x. So, oh shoot. Stop. We'll sleep like that. We can guarantee at least one x. So, for this first one, x is our GCF. Then x squared divided by x is x. We're going to add, or subtract really. We're going to subtract whatever x divided by negative 3 is, so we're going to subtract 3. Now, for our second equation, so this is our first equation. For our second equation, we're going to do, we can guarantee a negative 6 in both of these problems, because negative 6 is divided by this, but x isn't in there, so we leave x. So, negative 6 is our GCF, and x minus 3, because negative 3 times negative 6 is positive 18. You see how our coefficients are the same, being x minus 3. We're not coefficient, our variables, kind of, or second term, not term. Our second product, added, multiple, our second multiple is x minus 3 in both these equations. So, what we can do, this is how you know you factored by grouping correctly, if these two brackets are the same. So what we can do is we can take the first two terms and we can make a binomial. So x minus 6, our first two terms can be combined. Not terms, our first two multiples can be combined. Factors, our first two factors can be combined, and then our common factor between those two, x minus 3, we're multiplying those two to get the original binomial which that number came from, being x minus 6, x minus 3. Now, this is our binomial from our last problem after you factored. But sometimes when you're factoring, it'll say something about the Finnish flag because its battle flag is a rectangle, but its ship flag is a square. And it'll usually say that it has to add dimensions on the ship flag, so like it has to add 6 centimeters on one of these equations. So what would happen is you would go into here, add 6 to our final binomial. So the battle flag would be this instead of x minus 6, right? And if it was, let's say, minus 6, and we add 7, 6, 7, I know it wasn't funny, but we'd add 7, so x plus 1, x minus 3. But obviously, normally, it'll make a perfect square if it says it needs to, but it doesn't need to right now. So, the last standard for polynomials that I know of is the special products for squares, or squares of a difference. So, what happens here is we're going to use these squares of a difference. So only get one of my books, so I don't make something unfactorable. Here's a good one. X to the 4. X to the 4. What is that, plus? No, minus. Differences. So x to the 4 minus, let's say, 25. Everybody knows 25 is a perfect square, right? So, this binomial. This binomial can be simplified since it's a square of a difference, because we have a perfect square right here, a perfect square here. So if we were to square root these, I'm just gonna do a v with a dash. Upscore. I was gonna do this because I don't know how to put square roots on this thing. So the square root of each of these numbers would be work out to dang, this fucking text engine. X squared, because we divide by 2, because we're square rooting. And we get x squared and 5. Those are our two square roots. Now that we have this, what we're going to do is we're going to make our thing, because the square root of a distance, or a difference, the square of a difference is going to be a plus b times a minus b. So what's going to happen here is we're going to take our a, this, and our b. Well, a squared, b squared, square root of. So we take this, we make it to this. So our a is x squared and our b is 5. So what we're going to do is we're going to substitute that in. So this equals x to the, x to the 2 plus 5 times x to the 2 minus 5. And that is the square of a difference. Now, occasionally, when you are squaring differences, so we can use x to the 4 again. When you square a difference, or when you factor the square of a difference, something strange happens. Let me move all this. Not strange, but something different happens. Bring this over, because this is important. So if we replace this 25, if I can select it. If we replace this 25 with 256, well, we can put a square root on that. Right. So we do this. Now we're going to do our square to get, what's that? X to the 2 plus, this is square root of 16. Right, and then we're going to do the same thing but inverse, obviously. So x to the 2 minus 16. But you notice, x to the 2 minus 16 is also a square of a difference. So, we're going to simplify it down even more. So we take the square root from the second term. So leave the first one alone. And the second one, we square root it again. So we get x plus 4 x minus 4. And this is the true simplest form of this number. This term. Yeah. 2 times. Binomial, I think. I think that is, wait, let me check my standards. That is all the standards. If you have a question, ask your math teacher, leave a comment, and I might reply. Have a blessed day. Jesus loves you.